Good morning, everyone. Today I will be presenting our project titled Hospital Patient Record System, developed by our team Dua Farooq and Iman Siddiqui. This project focuses on designing a simple yet efficient way to manage hospital patient information using programming concepts in C language. In today's healthcare environment, the management of patients' records is one of the most important yet time-consuming tasks. Hospitals and clinics often deal with hundreds of patients every day, and keeping the records updated manually can be difficult. Our system provides a digital alternative to handle patient data quickly, accurately, and in an organized manner. This project highlights how programming can solve real-life problems and contribute to digital healthcare. Our project addresses the challenges hospitals face when managing patient records manually. Paper-based systems are often slow, prone to damage, and difficult to search through. By creating a digital patient record system in the C programming language, we provide a solution that simplifies record management. The system allows adding, viewing, searching, and updating patient information such as name, age, disease, and ID. It demonstrates how even basic programming knowledge can be applied to make healthcare processes more efficient and reliable. This project is a step-by-step towards the digital transformation of medical record keeping. The main objective of our project is to design a system that efficiently manages patient information digitally. To break it down, our goals include organized record keeping, ensuring that patients' details are properly stored for easy access, improved efficiency, reducing the time required to find or update records, minimized errors, preventing mistakes that commonly occur in paper-based systems, user-friendly design, making it simple enough for hospital staff to use without technical training. Educational purpose, helping students understand how arrays, functions, and conditions in C can be used to solve real-life world problems. Through these objectives, our system becomes both a practical hospital tool and a great learning project for beginners. Now, how it was solved. We implemented the solution by developing a simple and user-friendly C program that performs the main functions needed in a hospital record system. The program supports the following operations: adding new patient records, viewing all patients' data, searching for patients by ID or disease, updating records if corrections are needed. To achieve this, we used arrays for storing data and functions to divide the tasks logically. The system uses a menu-driven structure where users simply select an option to perform an operation. This makes it easy for even non-technical users to manage patients' data efficiently. Now, we have architecture of the system. The architecture of the patient record system is modular and simple, making it easy to understand and extend. Let's discuss its main components. Number 1, we have data storage. The data for each patient includes their ID, name, disease, and age. All this information is stored temporarily in arrays, allowing up to 50 patients to be managed at once. Number 2, we have modules of the system. Add patient. Adds new patients and assigns them a unique ID automatically. Then view patient displays all patient records neatly. And then we have search by ID or disease, which allows quick lookup of a specific patient. And then update patient enables corrections or modifications in the data. Number 3, we have program flow. The program uses a continuous menu loop that displays options repeatedly until the user decides to exit. This makes navigation intuitive and user-friendly. Number 4, we have technical terms and data handling. The system uses loops, conditional statements, and string comparison functions like strcmp to manage and search data effectively. Number 5, we have scalability. Though currently designed for temporary storage, it can be easily upgraded by adding file handling for permanent data storage or by integrating it with the database. Overall, the architecture provides a balance of simplicity, functionality, and flexibility. The flowchart represents the logical flow of how our system operates from start to end. When the program starts, the user is presented with a menu of options, such as add, view, search, update, or exit. Depending on the user's choice, the program calls the corresponding function. such as if the user selects add, it asks for patient details. If search is chosen, it looks for a record by ID or disease. The process continues until the user decides to exit. This flowchart helps visualize how user input drives the program logic and how different modules interact with each other. Then, we have results and assumptions. After developing the testing our program, we achieved successful results. The system was able to add and display multiple patient records accurately, search by both ID and disease with correct results, then update patient data without errors, and operate smoothly using the menu interface. We also validated the system with several input cases to ensure reliability. The only limitation is that it currently stores data temporarily, but that can be improved with file handling in future versions. Whereas in the assumptions, for the smooth working of the project, a few assumptions were made. We assumed that the system would handle a maximum of 50 patient records. All data is entered correctly by the user without invalid inputs. The program would run in a standard C environment on a computer system. These assumptions simplify the design and ensures the program performs efficiently during demonstration. Now we have patient management system flowchart explanation. First of all, start. The program begins with the start node. This is where the execution begins. Number 2, initialization. The system first initializes data by preloading 3 patient records. It also sets a variable total_patient is equal to 3 to keep track of how many patients are currently stored. Number 3, display menu. The menu appears, offering 5 key options for the user. Add a patient, view all patients, search patient by ID, search patient by disease, update patient details, and exit program. Number 4, we have input choice. The user is prompted to enter a choice from 1 to 6. The program will then follow a specific path based on the user's selection. Now we have decision and function flow. In choice 1, add patient calls the function add_patient. The system adds a new patient record if the list is not full. After adding, it returns to the main menu. In choice 2, view all patients calls the function view_patient, displays all existing patient records on the screen, then returns to the main menu. Choice 3, search patient by ID, calls search_patient_by_ID, prompts the user to enter a patient ID. If found, the patient's details are displayed, returns to the main menu. In choice 4, search patient by disease, calls search_patient_by_disease, prompts the user to enter a disease name, displays all patients suffering from that disease, then returns to the main menu. In choice 5, update patient, calls update_patient_input_ID. The user enters a patient ID and then updates the relevant details, returns to the main menu. Choice 6, exit, displays exiting program message. The program then terminates. 5. Return to main menu. After executing any choice except exit, controls returns to the main menu, allowing the user to perform more actions. In summary, the flowchart represents a menu-driven patient management system that starts with 3 patients, lets you add, view, search, and update patient records, and keep looping back to the main menu until you choose to exit. In conclusion, the hospital patient record system provides a digital solution for managing hospital data effectively. By converting manual record keeping into an automated process, this system reduces human error, improves accessibility, and enhances overall efficiency. Its modular design makes it easy to understand, modify, and expand, suitable for both small healthcare centers and as a programming learning project. This project proves that even a simple C program can have a meaningful impact in the healthcare domain by promoting accuracy, organization, and the digital transformation of medical records. Thank you for listening to our presentation. We hope this project demonstrates how technology can make healthcare management smoother and more reliable. Through this system, we have not only applied programming concepts but also contributed towards a more organized and efficient healthcare process. Thank you so much.
Thank you, Dua, for explaining the report. My name is Iman Siddiqui, and now I'll walk you through how this patient record system program actually works step by step, what functions it uses, how it's structured, and what each part does. Let's begin from the very top. At the start of the code, we have included two header files, hash include stdio.h and hash include string.h. The first header file, stdio.h, stands for Standard Input Output. It is used for input and output functions like printf and scanf. The second header file, string.h, allow us to use string handling functions like strlen, which is used to find the length of the string, strcpy, which is used to copy one string into another, and strcmp, which is used to compare two strings. Now, among these three, we'll be using strcpy and strcmp in our program. After that, we have declared few variables which can be accessed by all functions in the program. First, we have integer choice, which stores the user's menu choice. Then we have integer id 50. This is an array, meaning instead of writing separate variables like id1, id2, id3, and so on, we can store up to 50 patients' ID using an array. Next, we have char name 5050. This is a two-dimensional character array, which means it can store up to 50 names and each names can have up to 49 characters. The 50th spot is used for the null terminator that marks the end of a string. The same idea is applied to disease 5050 array. Now, the integer age 50 is used to store the age of each patient since age is a numeric value. Finally, we initialized total patient with 3 because at the start of the program we have already added 3 patient sample record. Now, let's move on to the functions. We have created 5 main functions in this program: add patient, view all patients, search patient by ID, search patient by disease, update patient information. The first function is void add patient. The word void means that this function does not return any value, and the empty parenthesis shows that it doesn't take any arguments either. Inside this function, the very first thing we did was to check whether the list is already full. If total patients are greater than or equal to 50, we can't add any more records, so a message is displayed that patient list is full and the function returns immediately. Otherwise, we continue adding a new patient. We displayed a simple heading and then assigned a new patient ID automatically by adding 1 to the current total number of patients. This way, IDs are generated sequentially 1, 2, 3, and so on. For example, if there are already 3 patients, the next ID will be 4 because 3 plus 1 is equals to 4. Then we use scanf statements to take input from the user. First the patient's name, then disease, and then age. We use this instead of %s because it reads the full line with spaces until enter is pressed. It allows multi-word inputs while %s reads only one word. For example, if the name Ali Khan is entered, if we'll use %s, then it will ignore the word Khan and it will only display Ali on the screen. While if we use this, it will read both the words that is Ali as well as Khan. After all details are entered, we increment the total patient count and print the message patient added successfully. Now we have void view patient. Again, the word void shows that the function doesn't return anything. If there are no patients means if total patients is equal to 0, we simply print no patients available. Otherwise, we print all patient record using a for loop. The loop starts from the index 0 and runs until it reaches the total number of patients. Since arrays start from index 0, this ensures that every record is displayed properly. Inside the loop, we print the ID, name, disease, and age of each patient. Then we have the search patient by ID function. We first ask the user to enter the ID they are searching for. Then, a for loop checks every stored record. If the entered ID matches an existing ID, the program displays the patient's full record, that is, their ID, the name, disease, as well as their age. If no match is found, it simply displays the message that no record found. Now I'll explain the function search patient by disease, which allows the user to find all patients having the same disease. The first line defines a new function named search patient by disease. It has void return type, again meaning it doesn't return any value, it just performs an action. In the second line, we have declared a character array called search disease, which will store the disease name entered by the user. Basically, this acts as an input variable. Then we declared an integer variable called found and initialize it with 0. This variable is used as flag, meaning it keeps track of whether any matching patient was found or not. Next, the program asks the user to enter the disease name to search for. The input entered by the user is stored in the variable search disease using scanf. The next line simply prints a heading showing which disease the program is now searching for. It uses %s to display the disease name entered by the user. Now we start a for loop that runs from I is equals to 0 up to total number of patients. This means the loop will check each patient record one by one. Inside the loop, this if statement compares the disease name stored in the array with the name entered by the user. The comparison is done using strcmp as told before, which stands for string compare. It checks both string character by character, and if they are exactly the same, it returns 0. So this condition becomes true only when a perfect match is found. If match is found, the program prints the complete details of the patient, their ID, name, age, and disease, followed by a separating line for clarity. This part ensures all matching patients are displayed properly. Here the flag variable found is updated to 1. That means at least one record has been found successfully. Finally, once the loop finishes, the condition checks if no matches were found. Here, instead of writing if found is equals to 0, I have written if not operator found. Both means the same thing. In C, the exclamation mark is logical not operator. It simply reverses the truth of value of the variable. So when found is still 0, meaning no patient record was found. If this condition becomes true, the message is printed no patient found with this disease. It's just shorter and cleaner way to write the same condition. So, overall, the search by disease function allows us to find multiple patients suffering from the same illness. It uses the string comparison function to match disease accurately, and the found variable ensures that if no record matches, a proper message is displayed. This makes the system very useful for quickly identifying patients by illness name. Next, we have update patient. The logic is similar to searching by ID. We ask the user to enter the ID of the patient whose record they want to update. Then we loop through all records to find that specific ID. If the entered ID is found, the program allows the user to update the name, disease, and age, all taken through scanf. Finally, it prints record updated successfully. But if the ID isn't found, it displays the message no patient found with this ID. Let's look at the main function, which is the heart of the program. First line defines the main function of the program. It is the starting point of execution for any C program. Int means it returns an integer value, usually 0 for successful execution. The word inside parenthesis shows that it doesn't take any command line arguments. Here we have manually entered data for 3 initial patients using strcpy to copy names and disease into their respective arrays. In C, we can't assign one string to another directly using the equal sign. That's why we use the strcpy function from the string.h library. The syntax is very simple. It's written as strcpy destination, source. Here destination is the variable where we want to copy the string, and source is the original text. For example, if we have written strcpy name 0, Muhammad Umar. It means that the text Muhammad Umar is copied into the first element of the name array. Each patient gets its unique ID and the age is assigned normally since it's an integer. This gives us some sample data to work with when the program runs. Next, we start an infinite loop using while 1. This keeps the program running until the user decides to exit. Inside the loop, we display the menu and let the user perform different operations. Here, we display the menu. It shows all the options available in the system so the user know what actions they can take. Then the program asks the user to enter a number corresponding to their main menu choice. The input is stored in the variable choice. We then use a switch case statement to decide which action to perform based on the user's choice. If the user chooses 1, the add patient function is called. If they choose 2, view patient is called, and so on. If the user chooses 6, it prints exiting goodbye and terminates the program using return 0. The default case handles any invalid input by displaying a warning message. Finally, return 0 indicates that the program executed successfully. This is the end of the main function and the program. So, in main function we initialize sample patient data, display the menu repeatedly inside a while loop, use a switch case to call different functions based on user choice, and finally we exit safely when the user chooses option 6. This main function ties together all the other functions to create a complete patient record system. Now that we have seen the code and how each function works, let's see the program in action. I will demonstrate adding, viewing, searching, and updating patient record so you can see how the output appears on the screen. When we first run the program, the main menu is displayed at the start of the program. The menu shows all the actions the user can perform. The program waits for the user to enter a choice. Let us enter first option choice number 2, that is viewing all patient. So, we can see here that the program displays all the pre-initialized patient records. Each record shows the ID, name, disease, and age. The separator line is printed after each record for clarity. And again, the menu is displayed and the program waits for the user to enter a choice. Let's enter option number 1, that is adding a patient. So now the program asks to enter the name of the patient that we have to add. Let us suppose that the name of the patient is Now the program asks to enter the disease that Hira is suffering from. Now it asks to enter the age of the patient. Now it shows the message that patient added successfully, and again the menu is printed. Let us enter option number 3 now, that is search patient by ID. So suppose we are entering here 2. The program searches for the patient with ID 2. Since the record exists, it prints the full detail. The name of the patient, that is Fatima, the disease she is suffering from, and the age. If we enter ID that does not exist, like we enter 10, it will display the message that no record found. Now let's select option number 4, that is search patient by disease. The program asks to enter the disease. Let's enter flu. Now the program has displayed all the patients with the disease flu. Number 1, Fatma Siddiqui, and number 2, Hira. You can see here the program displays all patients who have flu. Notice how both the first and newly added fourth patient are shown. This demonstrates that the function finds all matching records using the found flag and strcmp comparison. For example, let us again enter the option 4. And if we enter the disease that does not exist, like cancer, it will display the message that no patients found with this disease. This ensures the user gets clear feedback in all cases. Now let's choose option number 5, that is updating patient. Here the program asks To enter the patient ID, we have to update. For example, let us select 3. Here the program updates the record for patient 3. Now the program asks to enter the new name. Let's enter. It asks to enter the new disease. Let's enter fever. And then the age of the patient. And then it displays the message that record updated successfully. If the entered ID does not exist, the program prints the message, no patient found with this ID. Let us demonstrate this too. Here I'll be selecting option number 5 again, and I'll be entering ID number 8. So you can see the message that no patient found with ID number 8. Finally, when the user chooses option number 6, the program prints exiting and the message of goodbye. This ends the infinite while loop and safely closes the program. So, in summary, the program output demonstrates the following: view all patients, adding patients, search by ID, search by disease, updating patients, and exiting the program. The program always gives clear messages, success, failure, or no match, so the user knows exactly what happened. So that brings us to the end of our presentation. So in conclusion, our patient record system demonstrates how arrays, string functions, conditional statements, and loops can be combined to manage multiple records efficiently. It's a simple program, but it shows the core logic behind real-world record management system. Thank you.